Hello, my name is Ashley Pearson. I'm in Miss Lupher's first period class. This is my I Speak Math project. I did the level 4 activity, and for my two options, I chose to do applications of trigonometric functions. So I'm going to do 3 examples today. One very simple one on a very simple triangle, and then 2 that are a little bit harder than the first one, which include the use of the law of sines. So here's my first example. It reads, a ladder leans against a brick wall. The foot of the ladder is 6 feet from the wall. The ladder reaches a height of 15 feet on the wall. Find the angle the ladder makes with the wall. So using this, we can draw a diagram. And if we look at this diagram, we know it's going to be a right triangle. So we can label each of the sides. The hypotenuse can be the ladder. The bottom leg is G for ground, and the right leg is W for wall. So the right leg is 15 feet because it says that the ladder reaches a height of 15 feet on the wall. And the bottom leg is 6 feet because it says that the foot of the ladder is 6 feet from the wall. And here I am writing in the right angle, a little too late there. So now I'm indicating which angle it is that we're looking for because it says that it is the angle the ladder makes with the wall, and that is the angle in which the ladder line and the wall line meet. So now we have 2 sides that we know the measurement of. And yes, my paper for my example did just fly away. But anyways, so we have 2 sides that we know the length of. And I determined that they are the opposite and the adjacent. So that means we need to use the trigonometric function tan. So we took the tangent of x. We said that tangent of x would be equal to the opposite, 6, over the adjacent, 15. So here I am setting that up, and my writing gets a little bit cut off right now, but that's just because Beth, my handy-dandy camera woman, isn't the most talented cameraman ever. She shouldn't quit her day job. But then, since we are looking for the angle, we have to take the inverse tangent of the values that we do have. So it's the inverse tangent of 6 over 15 would be equal to x. And then if you plug that into a calculator, you get that x would be equal to, and here I am pausing to actually write it in the calculator, and just a nice handy pause there. So it would be, x would be equal to 21.80, and then some nice decimals. So we can round that off to 22. So I said that that angle would be 22 degrees. And now on to example 2, which reads, a ski lift begins at ground level, 0.75 miles from the base of a mountain whose face has a 50-degree angle of elevation, as shown in the accompanying diagram, which isn't really an accompanying diagram because I still have to draw it. The ski lift ascends in a straight line at an angle of 20 degrees. Find the length of the ski lift from the beginning of the ski lift to the top of the mountain. So now I'm going to draw out that diagram that's not really accompanying. So we know that this isn't just one triangle because it is both the full triangle of the ski lift and the back of the mountain and the ground, but there's also the front of the mountain. So now we need to label everything. So we can say that the bottom left half of the bottom leg is G for ground, and then I put that the bottom right half is M for mountain. The left hypotenuse is SL for ski lift, and then the right leg is just M again. So now I'm going to fill in the information we know. So we know that G is 0.75 miles, and my M kind of gets smudged into my G, but you can still read it, it's fine. And then that angle there, the angle at which the mountain goes up, is 50 degrees. And then the angle at which the ski lift ascends is 20 degrees. So here I am filling that out. And then I'm putting X at the ski lift because that's the length we're trying to find. And then I'm saying that the bottom line is a straight line, so it has to equal 180 degrees. So we know that the right part of that is 50 degrees from the elevation of the mountain, but 180 minus that 50 degrees lets us know that the other angle is 130 degrees. So we know that a full triangle has to be 180 degrees. That means that the right angle that we have marked is 90, and then we also have marked that the other angle is 50. So 180 minus 90 minus 50 lets us know that the top angle right there must be 40 degrees. And then we can use the same principle for the left triangle, where it must be 180 degrees all the way around. So we have 180 minus 130 minus 20 lets us know that the upper angle for that triangle must be 30 degrees. So now I'm writing down the law of sines. So the law of sines says that the sine of one angle over the length of the line across from it, directly opposite to it, is equal to the sine of another angle in the same triangle over the length of the line opposite from that angle. So using that, we can figure out how long the face of the mountain is, so the second hypotenuse. So now I'm going to just plug that formula in using the information I have. So I'm going to mark down which angles I'm going to use and what their opposite line lengths are. So here I am writing that the sine of 130 over x, which is the line opposite to it, must be equal to the sine of 30 over 0.75, because 30 degrees is in the upper right, so the opposite length would be the 0.75 miles, and at the bottom, as our arrows show, I've plugged in the sine of 130 and I got 0.76604, and a much larger decimal than that, but I decided to round it off to 5 places. And then I did the sine of 30, which is 0.5, and then I just put their denominators, so everything, so 0.76604 is over x, and 0.5 is over 0.75, like it was in the last one. And then here I am going upwards and cross multiplying, so 0.5x, and then I'm going to multiply in the calculator 0.76604 by 0.75, and I got 57453, and I had to erase the SL marking that it was a ski lift so that you could actually read it. So then we are trying to get x alone, so we divide by 0.5 on both sides. And when we do that, we get that x is equal to 1.149, and then some more decimals. But then I decided to round it off to 2 decimal places. So it's 1.15 miles. So here I am writing that final answer. And right as I was writing my units, I got down x equals 1.15. Beth drops my phone. So I cut it off before you actually see the tragedy happen, but I promise I did write the units, which are miles. So the final length of the ski lift is 1.15 miles. Now on to our third and final example. It reads, a ship captain at sea uses a sextant to sight an angle of elevation of 37 degrees to the top of a lighthouse. After the ship travels 250 feet directly toward the lighthouse, another sighting is made, and the new angle of elevation is 50 degrees. The ship's charts show that there are dangerous rocks 100 feet from the base of the lighthouse. Find how close the ship is to the rocks at the time of the second sighting. So based on this information, we can draw the accompanying triangle that we need. So here I am drawing that now. So the first triangle that I draw is just the triangle based on the first sighting, and then I add in another hypotenuse throughout the middle to show the second sighting. So here I am labeling. The ship would be on the left, and then on the right side I put LH for lighthouse, and at the bottom I put water because the ship is obviously floating along water. So the angle directly next to the ship at the first sighting is 37 degrees, as we know, and it travels 250 feet from the first sighting to the second, so the length between those two is 250. But for some reason I did not write the T for feet, so it's just 250 Fs for now. And then the right side angle underneath the second hypotenuse is 50 degrees. Here I am putting in the 100 feet from the lighthouse, which are where the rocks are. So now I'm labeling, and this little area that I label here with X, that's what we want to know. That's from the second sighting to the rocks. So it's from our original second mark to 100 feet away from the lighthouse. So again, I'm using the same principle I used in the last example, where that straight line on the bottom has to be 180 degrees. So 180 minus 50, 130. And then the whole triangle must be 180 degrees as well. So 180 minus 130 minus 37 is 13 degrees for that upper angle. So then here I am drawing in the right angle again, a little bit late. So for that triangle, again, 180 has to be the cumulative angle measures. So 90 and then 50. So 180 minus 90 minus 50. So we know that one must be 40 again. So here I am putting the T finally for the 250. So I have 250 feet, not 250 Fs. And I'm going to use the law of sines again. So here I am drawing an arrow to the measures that I'm going to use. So I'm going to try and figure out the length from the second siding to the top of the lighthouse. So I did 13 degrees and 250, and then 37, and then this variable right here. So here I am actually writing that out. So sine of 13 over 250 is equal to the sine of 37 over y. So then we're going to plug that into our calculator, and upon doing that, we have to rewrite it with our actual values rather than the variables. So then we get 0.22495 over 250 equals, and then I've plugged in sine of 37. So then I get 0.60182 over y. So now I'm going to do the same thing I did last time where I cross multiply. So I'm going to draw an arrow just to show where my work is going. So then I get 150.45, and then some more decimals after that, but I just rounded off to 2 places. And that's multiplying the 250 by 0.60182, and then 0.22495y. So now we're going to try and get y alone. So we're going to divide by 0.22, and then I just put dot, dot, dot to symbolize the other decimals. And we're going to do that on both sides. So then if I do another arrow to show where my work is going, you can see that y is equal to 668.832. And then I'm just going to put that equals y. So I didn't write it where actually y is. I just symbolized it over there. So now I'm going to do law of sines with the second triangle. So 90 to y, and then 40 to our measurement that is x plus 100. So now I'm going to erase my work that I did for this first law of sines just so that I have more room for my second. So here I am writing that the sine of 90 over, and then the length that I erased, 668.832, is equal to the sine of 40 over, and then I put another variable because it's not just x, it's that x plus 100. So here I am actually writing in to clarify that length right there. So that whole length I decided to just call a. So the sine of 40 over a. So now, again, I'm going to plug that into my calculator, and upon doing that, I decided to draw an arrow so you can see where my work is going. So sine of 90 is 1, so 1 over 668.832 is equal to, and then the sine of 40, so after plugging that in my calculator, I got 0.64279, and that's just a rounded off version, and that over a. So a is equal to, after you cross multiply, so it's just a multiplied by 1, so it's just a on the left side this time, so we don't have to do any division. So a is equal to 430. So then we're just trying to find x. So a was 100 greater than x because it was the length from the second siding to the lighthouse, and the rocks are 100 feet from the lighthouse. So 430 minus that 100 will give us x. So when we do that, simple math, it's 330. So at the second sighting, we were 330 feet from the rocks. Thanks for watching!